Hello, and now we are going to discuss the second law of thermodynamics. We have discussed till now the first law of thermodynamics, and you all know that first law is the law of conservation of energy. And it was dq is equal to du plus dw, heat exchange of the system with the surroundings leads this to the work exchange of system with the surroundings, and q minus w is equal to change in internal energy. And for a complete cycle, net heat exchange is equal to net work exchange. This we have discussed. That means energy is not wasted. Now let us discuss the second law of thermodynamics. The difference between first and second law is, first law is not a directional law, whereas second law is a directional law. So if you have this body and this body, they are connected by this rod, say heat is flowing in this direction. First law does not tell you the direction of heat flow. First law tells that energy is conserved, but it will not tell you that in which direction the energy is going to flow. It is the second law which tells you that energy flows from a higher to lower temperature. So second law is a directional law. Now what is this? Second law is also a law which imposes the limit on energy conversion. What does this mean? Limit of energy conversion. What we do here is, let me do an experiment. I am rubbing my hands, palms together. So what I am doing here is, I am doing the work. Where is this work going? The palms will become hot. So why they have become so? Because I have done work. So how this work has been converted into this heat? Both are forms of energy. There are some differences and some similarities. The main similarities is that both are forms of energy. This is similarity between heat and work, and they are both visible when they cross the boundary of the system. So they are called boundary phenomena. Otherwise you cannot say that this quantity is heat, this is work, just like temperature. So what is temperature? I can define it is the feeling of hotness or coolness of a body with respect to the other bodies. So similarly, heat and work cannot be quantified. Like this is heat, this is work. No. So they are experienced only when the energy in the form of heat or work is crossing the system boundary. Another similarity. And the dissimilarity main is the law of gradation of energy, high grade energy, low grade energy, high grade, low grade. Like water can flow from a higher level to a lower level, high level, low level easily, but for the water to make flow from a lower to a higher level, you will have to do work. You will have to use a pump and a motor. You will have to provide the energy for that. So high grade energy can be converted into low grade energy, but complete conversion of low grade to high grade is not possible. So this is called the law of gradation of energy. So I am rubbing my hands together, I am doing work, that work is converted into energy, heat. So there should be a medium for this, because there is a cause and effect relationship in nature. There cannot be it cannot be a single event which takes place in nature without the cause, and the event which is taking place is the effect of that cause. Like the wind is flowing, air is moving because of pressure difference, which is because of the temperature difference. Water is flowing because of potential energy difference. Current is flowing because of the potential difference. So there are different reasons for different events. or processes. So how this is converted work into energy or heat? This is converted through friction, because we have friction here. So now whole of this work is converted into heat. But can you think that whole of this heat can be converted back into work? That is not possible. So this is similar to an example, like this is a wheel which is rotating like this, and I have a brake here. When I apply the brake, the energy of this, which is this is absorbed by the brake, so the temperature of the brake increases by delta T. Now is it possible that I bring the brake again into contact with this wheel so that its temperature again reaches the initial value and the wheel starts rotating with the same speed? So this is not possible. Why? Because one is high grade energy, other is low grade energy. So high grade energy can be completely converted into low grade, but complete conversion of low to high grade is not possible. So here we have mechanical work, or the PDV work we have discussed, and here we have heat and other forms of energy. How do we drive a vehicle, car, motor driven vehicle, car or a bike, etc.? We put the fuel into the tank that when burns releases the chemical energy that is converted into the heat energy, and with the help of that we get the work. So if you put 100 joule of energy, chemical energy, or you get 100 joule of energy by burning that fuel, so how much of that will be available for the vehicle to move? So that is around 30 joule of energy that is available in the form of work. So 100 joule gets converted into 30 joule only, rest is wasted. So which law imposes this? As I've written here, this imposes a limit. That is the second law of thermodynamics. Actually, second law tells us about this. These laws of thermodynamics, they cannot be proved by using the first principles. They are experienced, so written in the form of a statement, and that's why we are studying these only. We cannot prove them. They happen in nature and we know them in their form. So 100 joule energy can be converted into 30 joule of work, 70 joule is wasted. This is the limit imposed by the nature. So if I have this thermodynamic engine and we have a source, it is giving Q1 energy to this. With the help of this is doing W amount of work. Then Q1 cannot be equal to W. Q1 has to be some part of it has to be wasted to the surroundings. Q2, temperature T1, temperature T2. So Q2 should have a finite value. If I apply the energy balance to this, total energy coming in equal to total energy going out, then Q2 is Q1 minus W. It means that suppose you are giving 100 joule of energy to this, and it is giving you a work output of 30 joule in a complete cycle, finite cycles. Then 100 minus 30, 70 joule of energy will be wasted. This is the limitation. We cannot use this. So we can improve the performance by decreasing Q2, but we cannot make Q2 equal to 0. So Q2 cannot be equal to 0. This is the limitation imposed by the second law of thermodynamics. So there are two statements of second law of thermodynamics. One is Kelvin-Planck and other is Clausius. According to the type of conversion of energy from one form to another form. So here I would like to discuss only the second law in this form only, that second law is a directional law. It tells us the direction of heat flowing from high temperature to low temperature. The flow of heat or heat transfer is governed by first and second law of thermodynamics. This is a very important question which may be asked even in an exam like UPSC, Indian Engineering Services, may be asked in the 12th class, or may be asked in an interview. So first law tells us that energy is conserved. Okay, there is no problem in it. Only the form of energy is converted, as you can see. Second law tells that flows from high to low temperature. It is having two forms, work and heat. Both are energy. High grade energy is work, low grade energy is heat and other forms of energy. High grade can be completely converted to low grade, but complete conversion of low to high grade is not possible. So that's why when we supply energy Q1 at temperature T1, this is source, this is sink. Source is like a furnace. Sink is like a water body or the atmosphere to which heat is rejected. Q1 energy is supplied, W is the work we are getting. Then Q2, which is equal to Q1 minus W, has to be rejected to the sink. This cannot be 0. So this is the second law. Now there are two statements of this which we will be discussing later on.